Are you tired of wasting hours cleaning laboratory glassware? Are you fed up with contaminated glassware messing up your experiments? Standard flask cleaning brushes are a pain to use and just don't seem to get the job done. You need the Grime Gremlin.
Hi there, Logan Grimes introducing the Grime Gremlin. From high school laboratories to professional laboratories, the Grime Gremlin will cure all of your complex cleaning conundrums. Just look at this standard brush. I mean, it looks like an infected caterpillar, and it bends like Jamaican limbo star. But not the Grime Gremlin. The Grime Gremlin crawls in and attacks the most stubborn debris in the hardest to reach corners. And once you bend it, it snaps right back, like a new pair of suspenders. We're going to do this in real time. You just take your water, bend the Grime Gremlin. The unique alloy of the Grime Gremlin allows it to slip into the tiniest of openings, bending but not plastically deforming. With almost no pressure, it hits those deep, hard to reach corners. Just look at that efficiency. It's hitting all the corners with almost no effort, and when I go to pull it back out, it snaps right back into place thanks to the nickel titanium alloy. But how does it do it?
Well, let me tell you, Logan, the Grime Gremlin utilizes nitinol and its unexpected properties. Our scientists spent countless hours developing the Grime Gremlin to the highest standards. Partnering with nitinol devices and components, both SM495 and SE508 nitai alloys were utilized in testing. The initial design used 0.06-inch diameter SM495 wire. The designated target AF temperature of 35 degrees Celsius allows for deformation of the martensitic brush upon insertion into the Erlenmeyer flask. The addition of warm water increases the wire temperature above 35 degrees Celsius, causing the wire to press against the side of the flask, maximizing cleaning efficiency. The high corrosion resistance of the black oxide finish allows the Grime Gremlin to outlast competitor brushes in harsh conditions. In order to obtain the ideal material properties for the Grime Gremlin, scientists tested the SM495 wire, collecting data at 3 different heat treatment temperatures for 3 separate times. Utilizing both bend-free recovery and differential scanning calorimetry, our scientists determined the AF temperature produced from the initial tests. However, with an as-received AF temperature of 60 degrees Celsius, the scientists were unable to produce an AF temperature close to the target AF temperature of 35 degrees Celsius, even through solutionizing the nitai at 750 degrees Celsius for 30 minutes. The 550 degrees Celsius sample for 30 minutes produced the fastest recovery when straightened and placed into boiling water. After analyzing the initial results, the scientists behind the Grime Gremlin decided that a switch to SE508 would better suit users' needs. By using the superelastic property produced through a sub-room temperature AF, you no longer have to worry about using hot water to use the Grime Gremlin. Just about any temperature water will do just fine. Once our scientists shifted focus to the SE508 alloy, a new design was created to facilitate the change in materials. This simpler design utilized the superelastic properties of the nitai wire, deforming the austenite phase into martensite when inserted into the flask. Once released, the brush snaps back into the Erlenmeyer flask shape. This new design does not require the addition of hot water to clean your glassware, making your life easier. Our scientists developed a new test matrix based on the SE508 alloy, using the TTT diagram to select certain temperatures and times. Shape setting took place at 500 and 550 degrees Celsius for 5, 10, and 15 minutes. After determining that the 550 degrees Celsius heat treatment for 15 minutes held the shape set closest to the initial value, our scientists began prototyping our amazing Grime Gremlin. Differential scanning calorimetry was first utilized to determine the AF temperature of the treated prototype. Due to unreliable results from the DSC tests, an ice bath was used to find the active AF temperature of 5 degrees Celsius. From these results, the Grime Gremlin will work well at temperatures above 5 degrees Celsius. Who's going to wash beakers in ice water anyway? Independent tests confirmed the effectiveness of the heat treatment produced for the Grime Gremlin. Team Coherency Strain produced satisfactory shape-set wire when presented with Team Lamina's jig and heat treatment procedure.
With all this technology behind the Grime Gremlin, it must cost a fortune to make.
You'd be pleasantly surprised, Logan. The Grime Gremlin is customizable and very affordable. Creating a specialized Grime Gremlin costs roughly $25, and we can manufacture a specialized jig to use and reuse for as many brushes as you need. Manufacturing costs may vary slightly depending on the size and shape of your container.
Some restrictions may apply.
After the jig has been made, it's only the cost of the wire and abrasive cleaners. The original Grime Gremlin only costs $3.05 for each new brush on the jig. Our technicians spend roughly 60 minutes carefully crafting each and every Grime Gremlin. The construction of the brush is done by skilled workers right here in the United States.
Let's see how the Grime Gremlin stacks up against the competition. Why would you want to do more work? Get the Logan Grimes Grime Gremlin now. For only $19.95, this is our lowest price ever. Technicians are standing by for your order. Call 1-800-555-5555. That's 1-800-555-5555. That's 1-800-7-5s. But there's no sevens, it's all fives, except for the 1-800. Call now, and for every 3 brushes you order, you'll get a free Shiba Inu puppy.
For more information about the science behind the Naitai Grime Gremlin, please see the website at the bottom of your screen.